Hey everybody, in this video we are going to look at trig ratios of any angle, angles in standard position, rather than looking at angles using trigonometry inside of constricted right triangles. When you do trig with angles inside of a right triangle, you're restricted to angles that are acute between 0 and 90 degrees. When you have angles in standard position, what you have are angles that can be infinitely large or indicate direction, so you can have positive or negative angles that are also infinitely negative, okay? That will just require more rotations, and since things overlap, we call that periodic, and the sign of any angle that lands in a certain position will give the same answer. So your answers for sine and for cosine and for tangent and the reciprocals will be periodic in nature as well. So let's get started. Here we go. First one we're going to do, I've just made a list of a bunch of things that we can do to just be sure that you are getting all the boxes checked when you have to graph an angle or draw an angle in standard position. So let's say the angle we have is 120 degrees. If the angle is given to you in radians, then you do the entire problem in radians. If the problem is given to you in degrees, then you do the entire problem in degrees, okay? So over here, theta equals 120. All right, what does standard position look like? Standard position is superimposed on the XY plane. This is your y-axis, this is your x-axis, right? The initial side, let's see what we can do here. I'm going to color coordinate. So we got initial side, terminal side, directional arrow, quadrant, quadrantals. What else was there? Reference angle. One, two, three, four, five, six. 1, 2, 3, 4. 5, 6. Okay. We'll try these colors in this order. Ready? Let's go. All right. First up, the initial side. Your initial side will always be found stuck to the positive x-axis. It does not move. It is always in that exact same position. Each quadrant, I hope you know, the x and y axes are perpendicular, so each quadrant is 90 degrees. We are looking at 120 degrees. You want to draw your terminal side, which is where the angle terminates as opposed to initiates. You want to draw your terminal side in a fairly decent place. It should look like you have a clue how big certain things are. So since this spot right here is 90 up here, well, I guess let me get ahead of myself a bit. I'm going to use purple, then I'm going to use this one. So I'm going to grab the red right now. So here we go. Quadrantals. The quadrantals before and after the angle are going to be 90 degrees up here. And, oh, is that going to show? Yes. 180 degrees right there. Okay. So the quadrantals, both before, quadrantal angles are angles that separate the quadrants, are 90 degrees and 180 degrees. 120, where is that in relation to those two? 120 is 30 degrees after 90, and it is 60 degrees before 180. So my terminal side is not going to be in the middle as much as it's going to be closer to the 90. And put a little arrow at the end of that right there. Beautiful. The directional arrow does not come out of the origin. Ugh. Don't do that. It comes off this side. If you come out of the origin, like, I can't tell if you know what you're doing because you probably don't. You're probably confused. So it has to come out of here, and I'm going to show that it went this way. Positive angles rotate in the counterclockwise direction. I will only have an arrow pointing at the terminal side. It comes from the initial side. Next, we are going to indicate the quadrant where the angle terminates. This is quadrant 1 over here, and then it goes in the positive angle direction. So I'm indicating quadrant 2 with a Roman numeral, not a 2 like you always write. That's called an Arabic numeral. Your quadrants are always represented by Roman numerals. Class it up, guys. Don't be some second-class mathematician. Use your Roman numerals when you're supposed to use your Roman numerals. Last but not least, our reference angle. The reference angle is always found between the terminal side and the closest x-axis. So that means my reference angle is going to be that angle measure right here. Another thing about the reference angle is it's always acute and it's always positive. Don't think that it's negative for any time or reason. If you want to use like a capital R to indicate the measure of your reference angle, you can use a capital R. I tend to like to use another theta, a theta, and I make it a subscript. That means a little below versus like an exponent, which is a superscript, okay? A little baby R for reference angle. So I'm saying an angle, reference angle, which one, you know? And I want to know, well, how big is that? In order to get that measurement, in here, what you would do in quadrant 2 is you do 180 minus your given angle theta. Given angle is 120, 180 minus 120, and we get 60 degrees. And because we are very careful, studious, responsible students, is that acute? Yes. Is it positive? Yes. So not only do you indicate it with a little arc, you also, I know you know where it is, you also indicate the measure. If the problem is given in degrees, you do everything in degrees. If the problem is given to you in radians, you do everything in radians. And that's it. Now, so far, I lost track of how long I've been recording. Okay, it's 7 minutes, 7:12. Let's do one more in, how about another degree or a radian? Let's do another degree. I'll do a separate video using radians, okay? So another degree measure. I'm going to use the same color coordinating, you know? So what I'm going to do is, my scissors handy, but, okay. All right. How's that? Decent? Okay, let's do another angle. This one, example 2, right? Theta equals, let's do more than one rotation, 560 degrees. Start off by drawing the XY plane on which my standard position situation is superimposed onto. That spot is called the origin, where the X and Y axes meet. The ordered pair of the origin is 0, 0. When you plot points or ordered pairs, the X coordinate comes first. That's your first number in the parenthesis, it moves it left or right, and your Y coordinate comes second, that moves it up or down. If you are confused by any of that, you're going to rewind that and you're going to listen to it 1,000 times, because you cannot be showing up to class in pre-calc and not know which one's X or Y and not know what the origin is. Okay, just looking out for you, you know? All right, so let's go ahead. Initial side. Well, that's a no-brainer because it's always in the exact same place. It's right there. Done. Terminal side. All right, we grabbed the red next last time. So if I'm going around and around we go, it's a positive angle, 560. 90, if you can count by nines, your life's a little easier. 90, 180, 270, 360, like 9, 18, 27, 36, right? 450, 540, so 540, and after it would be 630. Okay, so those are going to be the quadrantal angles both before and after the angle measure of 560 degrees. Hopefully you already know which one it's closer to. Next, the terminal side. Let's do that. So 560 degrees is 20 after 540, and it's 70 before 630. So it's going to be a good amount closer to that 540 degrees. So there you go, terminal side. Now for the directional arrow, a little different now. carefully. We're going to go around one full rotation. Do not clip it like underneath where you started because you're going to overlap and you can't count that way. That's one rotation. That means you're at 360 degrees. 450, 540, there we go. Right there, 560, directional arrow, done. Green done, blue done, purple done. Doing great. Next, let's do our quadrant that we terminate. This is quadrant Roman numeral 3. Then last thing is finding our reference angle. Your reference angle is the acute positive angle between the terminal side of your angle and the closest x-axis. So it's right there. In quadrant 3, when you want to find your reference angle, which we are calling theta sub r right now, you take your angle and you subtract, in this case, not 180, but 540. Like really the quadrantal angle that's right there. That's not on the screen. That's unfortunate. Can we still see everything? No, that's so sad. I'm upset because it doesn't fit. Okay. Okay. Not my proudest moment. How are you doing? Are we okay? So our angle 560 minus the 540. So we're going to get that our reference angle is 20. And make sure when it's degrees, you actually put the degree symbol. Don't make it too big so you think it's a 0. Make sure you put the degree symbol because the only unit that has no units is radians. So since radians is another way to measure angles, I might think you mean 20 radians, which is a perfectly plausible thought to have. And that's it. The end. So next video I make, which will actually probably be before this video in the thumbnail situation at the end, I'm going to do 2 radian examples. I didn't do a negative example this time. Maybe I'll squeeze one in a batch of examples later. It's the exact same thing except you go counterclockwise, but oh my god, maybe I should do one because there's a concern. I know, I was going to end it. How long are we? It's gross. You're not going to want to watch more than 12 minutes at a time. Oh, sorry, I'm hitting the microphone. Yeah, no, doing a separate video. Keep your eyes peeled. If you understand, can handle, go ahead. You know what to do. If not, go ahead, do it. Comment, questions, requests, concerns. Hope you feel smarter.